in this lecture, we will talk about the application of hyperbolas. And this question says that the airplane is flying along the hyperbolic path. This is hyperbolic path illustrated in the figure. You can see this is a hyperbolic path. The airplane flies like this. If the equation of the path is this one, okay, that's the equation of the path, and this is the hyperbolic equation, and ask us to determine how close the airplane comes to a town located at 30. Okay, let's say this is the one of the vertex of the hyperbola, and then this is the origin. Okay, and this town is 3 miles away from the origin. So the question here is that determine how close the airplane comes to a town. You know, maybe somewhere here is far, here is far, somewhere around here is very close. Okay, so ask us to find out how close means what's the minimum value between the distance of P and this town 30. Okay, so ask us to find out the minimum distance. And in this case, if we let the D denote the distance between the airplane and the town, so then D would be this part. Okay, you may put D here. D here. By the distance formula, we know x minus 0 squared minus 3 x minus 3 squared plus y minus 0 squared. Choose the square root is the distance. If we do not choose the square root, then would be distance squared. Okay. Now we got to FOIL this x minus 3 squared like this. Okay, that's x times x is x squared. X times x, and then x times negative 3 is negative 3x. Negative 3 times x is another negative 3x. So you have a 2 negative 3x, and negative 3 times negative 3 is 3 squared. And y minus 0 squared is just y squared. Okay. Now, remember, right here, this pxy is still on the hyperbola. So, this xy satisfies this equation. Okay. We got to use that. And if you plus x squared on both sides, you then have a positive negative x will cancel each other, x squared. Then you then have a 2y squared equals x squared plus 32. Okay. Now, if you then divide it by 2, you then have a y squared equals 1/2 x squared plus 16. These 2 goes to everyone, goes to x squared and 32. Okay. Now, since we have a y squared here, we have a y squared here, and then xy satisfy this equation, you can replace this y squared by this quantity, okay? By this quantity. So let me erase that and put in this one, okay? So we are here, and then we have x squared minus 6x plus 9, and then plus 1/2 x squared plus 16. Okay. Now you have two constants, 9 and 16, and you also have a x squared. Remember, here is 1 in front of it. So then what we get will be 3/2x squared, because 1 plus 1/2 is 3/2. 1 equals 2/2. Okay? And then you combine those two together. The -6, you copy it. Okay. Combine 9 with 16 together, you have 25. Alright. Remember, this is a quadratic function. So here is our a, and here is our b, okay, and here is our c. Alright. If you remember that the characteristic for the quadratic function, you will see that if x equals negative b over 2a, then this quadratic function will have either maximum or minimum. Since here the coefficient of x squared is positive, so the quadratic function will choose minimum when x equals negative b over 2a. So negative, here is, then b is also negative, so you have a -6. Then divided by 2 times a. A is 3/2, so 3/2. Then you have negative is positive. 2 cancel each other. So you have 6 divided by 3, which gives us 2. Okay? Then then d squared will have a minimum. Minimum means what? That's the closest distance. Okay, we'll have a minimum value. Okay, so now you plug in 2 over there. What do we get? Actually, we get is the distance squared, right? So now we don't need distance squared. We just need distance, so you choose the square root. Then d equals radical 3 over 2 squared minus 6 times 2 plus 25. What do we get? Here you cancel 2, then you have 2 times 3, that's 6. Okay. And here is negative 12 plus 25. What do we get? 12, 6 minus 12 is negative 6, plus 25 is 19, positive. Okay, 19 approximately is how many miles? You do square root 19, there are 2 different ways. Okay, so radical 19. So it's about 4.35 miles. Okay, you may write approximately 4.35. Yes, 4.35 miles. Okay. Okay. You may leave like that. Radical 19. So it depends. Yeah. So this one is a little bit comprehensive one. You need to understand the distance formula. You need to recall the quadratic function's characteristics. At what value the quadratic will choose minimum. And we also want to include the hyperbolic function. Replace y squared by the expression, so you get the quadratic function. So this one is a little bit comprehensive. It's not that hard, but it involves a lot of knowledges. Okay, so I will see you next time.